Right. Hello everyone. Sige. So, um, first off, no, good luck sa midterms bukas. Room assignments probably in the fourth floor. So, kung wala pang announcement by tomorrow morning, just hang out in the fourth floor before the exam. Kasi dun din yung early and late exam, right? Um, so, ayun lang, no? But as soon as there are room assignments, I'll relay it on Discord immediately. Yun lang, no? Sige. So, sige. So, let's get on with the lesson. So, more amplifier, small signal analysis. No? Right. So, last time we left off with this, no? Meron tayong Vin with a decoupling capacitor. Tapos, meron tayong resistor dito sa base to produce the bias that we needed for the NMOS, no? Meron tayong load resistance, VCC. Ayan. And then this is VL. Right? And then we took the small signal model of this and found that it becomes this. This Vin, R pi, RB, GM, Vin, R out, and RL. And V out. Right? And if you remember, no, all this does really is turn the input resistance into a parallel, no? So R pi parallel RB, and the output resistance also turns into R out parallel RL, no? And the overall GM becomes just GM. And now the gain is negative GM R out parallel RL. Right? So what we got from that is that if we take a unilateral two-port model of something, no? Anything really. Tapos dinagdagan natin siya ng parallel RB sa taas, ng extra resistor sa taas, no? Pa RB. Tapos extra resistor sa output side na RL. This is all it does, no? Maglalagay lang tayo ng parallel, no? And this fact, no, is going to be useful for what we're going to do, no? So, come in the Degenerate CE amplifier. So, we've discussed this before, really. But this is what happens, no, for a degenerate CE amplifier. So for the degenerate CE amplifier, we have RC, VTD, VCC rather, and RE, no? Meron tayong resistor sa emitter natin. no? So, nagdagdag tayo ng resistor sa emitter. So, again, why do we do this? Well, to make the circuit more stable against changes in the transistor, no? Which tends to happen, right? It happens all the time, no? So, pag nagbago yung metal contact mo, for example, um, or pumangit yung connection niya dun sa breadboard, no? Even if hindi mo palitan yung transistor, you do experience a lot of variations, no? In the behavior of your transistor over the course of a lab class, no? So, um, what can happen? Well, as mentioned before, when the transistor changes, for example, IC can increase, no? And if IC increases, magmo-move yung DC operating point natin, right? So that's not good, right? We don't want that. And in a normal amplifier, no, kapag tumaas si IC, bababa si V out, right? In a normal C amplifier. But in this case, no, IC, well, approximately IC, no, that's IE, also passes through RE, no? Which means that the voltage across RE, no, which is VE, increases, no? So, if that thing increases, VBE decreases, decreasing IC, no? So there's a negative feedback loop causing IC to actually remain stable when it tries to change its own value, no? Well, when the transistor changes, no, IC remains relatively stable, no, for a degenerate amplifier. That's why we like it, no. But this thing has consequences for the small signal model, no. So first, no, let's do the start of the analysis, no. Let's do the small signal model. So we start with the V in. The capacitor disappears, no? Because we are, because it's a capacitor, no? So we assume we have enough frequency in order to use this capacitor. No, hindi tayo DC, right? And then, we enter the transistor, no? Well, may RB dito sa taas, but we enter the transistor. Tapos meron tayong GM VBE, no? And VBE is this. And then this is R out. And this is RE. Tapos meron tayong V out. And then RL. No? So now it's no longer as convenient to calculate as it was before. No? The problem is, hindi na to grounded, no? Dati grounded yan, no? For the previous session, grounded yan. But now we already have this, and we now have a intermediate voltage signal VE. No? And that's a problem with this circuit, no? It complicates our calculations now, no? So, to ease the complications in the calculation, ang gagawin natin, we're going to take this part first, no? Meaning, we're going to calculate the two-port equivalent of this portion first before adding RB and RL, no? So, ano magiging itsura ng circuit na yon? If we do that, then we'll have this circuit, no? We're gonna have some sort of Rin prime, GM, well, GM prime V in and then R out prime. No? Those are our answers to the red region. No? Kapag kinuha natin yung two-port equivalent niya. And then, we add back RB and RL. No? So, if we get the unilateral two-port equivalent of the red area, then we get the red part of this thing, which we then add RB and RL back to, and we'll finally get the full stats, the full parameters, which becomes R in prime parallel RB, R out is R out prime parallel RL, and GM is GM prime. And we know this because we've already done this analysis. That is this network. No? So all we really need to do is to solve the red part and do this parallel thing, and we'll be able to get the answer. No? So is that clear to everyone? Sige. If so, let's proceed. No? So let's calculate the output resistance. No? Of the red part. No? So it's BE. That's not.
Let me know for this. Guys, I'm thinking the best or the latest that we should provide.
So ito lang naman yung gusto nating calculate. No? This is the red part earlier.
Develop the purpose for that. I can see that you already have a site map.
So we want to calculate R out prime, no, for this. And we get that by calculating V out over I out, given V in is grounded. No? So let's do that. So ground V in, and then let's calculate. No? So I'll call this VE. And, okay, so first thing we observe here, no, is, so observation lang to, no, VBE is V in minus VE, no, for the general circuit. But since V in is 0, it's now negative VE, no? So this thing, we're gonna transform it, no? This becomes GMVE, kaso negative yan, so we're going to reverse the direction. Alright? So since VBE is negative VE, we reverse the direction of GMVBE and replace it with VE. Alright? And then, we're going to start with the calculation, no? So we have an IO coming here, well, an I out coming in here, and a V out, and we want to get the ratio V out over I out, no? So yun ang gagawin natin. So first, let's KCL at E, no? KCL at the emitter. Alright? So we're gonna have VE minus V in over R pi plus GMVE plus VE minus V out over R out plus VE over RE equals 0. Right? And pushing the numbers around, we get VE is equal to VE times 1 over R pi plus GM plus 1 over R out plus 1 over RE is equal to V in over R pi plus V out over VE minus V in. VE lang yun, no? Naka-ground nga pala si VE, no? So VE over R pi lang. So wala tayong V in. V out over R out. So yun lang siya. Alright. And then, number 2 is, let's do KCL at V out, no? So all we really need to say here, no, is I out is equal to negative GMVE plus V out minus VE over R out, no? So ito plus ito. Right? And these are the no? So meron na tayong two equations, three unknowns. We just have to eliminate VE and we find a relationship between V out and I out, no? So yun yung gusto natin gawin. All right. Well, first let's clean this thing up.
This kind of plans that
V out over R out tapos minus VE times GM plus 1 over R out.
so
Right.
means that
Tapos, I'd like to clean this up, no? So, I out times R out is equal to V out VE times GM R out plus 1, no? And we find the intrinsic gain dito, no? Which is kind of good. All right. Tapos ito, I'd like to transform it as well, no? Actually, no, let's not transform it for now, no? So, gagawin natin is VE times R out times this is equal to V out, no? And then we're just gonna copy paste this down here, no? So we substitute 1 into 2. We get this. No? Ay. Sorry, baliktad pala, no? Ito dapat pala yung nilagay natin sa kabila. Redo. So this thing turns into VE in terms of V out, no? So VE yung i-eliminate natin.
Because adjustment that might be
Yeah.
possible for this.
All right? Which means that this is V out, tapos itong VE na to, ang papalitan natin ng neto. All right. And then we have no V out, R out, V out, 1 minus GMR out plus 1, 1 over this thing. Yan. And then finally, we have V out over I out
Annie, can I ask, is
is
it
equal
possible for
to
us to start with my projects? Okay. Question for you.
R out
Does it make
over
sense and start with my projects before article generation?
over this, no? All right. So now we have this thing to work with.
Because for the article generation, that's why we're thinking of this. Because if my
Okay.
projects is
So, ngayon, this portion is important, no? So, sige, for us not to get too lost, no? I will first state that this thing is going to turn into 1 plus GM RE. All right? So, we find, no, that this is R out prime, no? And all that happened is we increased R out by a factor of 1 plus GMRE. That's the effect of the emitter degeneration, no? So what I'll show is this thing actually turns out to be 1 plus GMRE. All right?
a natural, a
Sige.
natural extension, yeah. A natural extension.
Ayan, no? So I'll start with this. And then let's see. GM R out plus 1 over R out is actually GM plus 1 over R out, no? So in fact, this is copy paste it again para kita. In fact, this becomes GM plus 1 over R out up here. All right? So, I'm pretty sure it's all a lot of algebra, but this part is important. No, this part is really important for us to accept nga, no? I don't want to just throw this out there, no, because that's what I think essentially no that's that in the slides kasi there's like a time skip no from something like this to that, no, and I want to show that it actually does happen. So now that we have that, no, I'm going to multiply this thing, no, to both sides of the equation, no. Essentially, ang mangyayari is pupunta to sa taas, right? And then
No,
we promote this to the 1, no? So replace nyo yung 1. And now what we have is this thing minus GM minus 1 over R out, no? And the good thing about this is we cancel GM because minus yun plus yun, and we cancel 1 over R out. All right? So this becomes 1 over R pi plus GM plus 1 over R out is 1 over RE over 1 over R pi plus 1 over RE. All right?
Yes.
So this one is a very much simplified form of this. No, I like it. I like this a lot more. No? And I'm going to apply one last thing. No? I'm going to multiply RE to both sides. No? So this becomes RE over R pi plus GM RE. No? So the senses should be tingling now. We already have what we want. Plus 1. No? So 1 plus GM RE is now here. And then we have RE over R pi plus 1. Right? And essentially, this is the closest you can get without assumptions. No? So, what really happens here is the following. No? In typical design, no? So let's bring back the emitter degenerate amplifier.
1 December is October for the
Oh, actually, hindi naman natin kailangan yun. Typically, this is very low, no? It's like 200 ohms. In fact, actually, I think like I went down to the tens nung ginawa ko yung project ko sa 52, no? But this is typically very low. And the reason why is because you have IC, right? You have IC pouring down, and IC kind of also passes through this, no? That's IE, which is almost IC, di ba? If IC is passing through this, malaki yung voltage dito, right? So you'd like to reduce that as much as possible by by lowering RE. Because if you don't, VBE is going down, meaning that your transistor will not be turning on if RE is too high. No? So that's why RE is typically very low. No? In fact, we will assume here, no, that RE is actually much less than R pi, much less than R out. No? Bakit? This thing is on, R out is typically greater than 50K, right? R pi is around, I don't know, 5 to 10K. No? So since RE is in the hundreds to tens, then this is a fair assumption. No? And it will make it pretty. Bakit? Because with that assumption, we can eliminate this part, and this part. No? RE is much less than R pi, so this is 0. RE is much less than R out, so this is 0. RE is much less than R pi, so that's also 0. No? So really, what we get is GMRE plus 1 over 1, which is GMRE, no? With the assumptions. All right? Which puts us here, no? So in summary, no? R out prime, well, actually, in summary, sige, let's scroll back up, no? In summary, R out prime turns out to be R out plus, R out times, there's a bad spot, 1 plus GM RE. All right? And the kind of, well, okay, it's kind of copium, no, I guess, but, ano, to me, I try to tell myself it makes sense. Bakit? Because of this, no? For this circuit, di ba formerly R out yung output resistance na nakikita natin, which kind of makes sense naman, no? But now we have RE, no? And the thing is, RE, no, V out now has its voltage divided across RE, R out and RE, no? So it makes sense na lalabas si RE dito. Now, bakit siya multiplied ng GM? Because VE is across RE and VE also is multiplied by GM dito, no? Now, for the circuit, original circuit point of view, no, dito, what kind of makes sense to me, no? The explanation that kind of makes sense to me is the fact that, no, well, si RL, no, kaso tinanggal natin si RL kanina, like, we'll add it later on, but here, no, we see R out, no, from V out, we see R out, tapos we see RE. Kaso, in order to get to RE, we went through the amplifier first, no? Which means that we need to add some sort of gain to refer RE to the other side, no? To make it as if it's here, right? we need to pass through an amplifier, which means that we kind of need to amplify it. No? At least that's the intuitive explanation for me. No, that's what I think it means, right? Because I don't want to. That's why I really didn't want to stop here or here, no. But unfortunately, for the last class, I couldn't remember for the life of me how to get from this thing to this thing. But now I do remember, no. So, and this one is recorded, so they could look at it. Kaso, this one is much prettier and it has a good explanation, no? It kind of makes sense, the answer, when you look at it, no? Because the form is pretty as well, no? All right. So that's what it does to the output resistance. By the way, any questions so far? Because now that we've done that math once, no? Spoiler alert, we're going to have to do this multiple times, but since we've already done it once, I'm just going to reuse that, like the fact that this thing turns into that thing. So we just need to make this appear, and it's actually going to appear for GM and R out R in as well. No? All right. Sige. So if no one has any questions, then I'll copy paste this to the other notebook and our other page. And then we can proceed with one of the others. No? So now, now let's calculate GM. Right? GM prime, rather. No? So GM prime is I out over V in this circuit, but V out is 0. All right? So V out, we set that to 0. Well, wala pa ding easy, no? So wala tayong cancel dito. So then let's proceed na lang to the analysis kagad, no? So first we do KCL at VE, no? And since I already did that, I'm just gonna copy paste that, no? Like, I don't want to write it again. So that's VE minus V in, no? Alright? Tapos, well, papalitan natin si V out dito, no? 0 si V out dun. Alright. So now we have this. And the simplified form is now VE times 1 over R pi plus 1 over R out plus 1 over RE plus GM plus VE plus VE plus VE is equal to V in. Kaso mag-multiply tayo ng R pi kay V in. No? So now, the final form is ito, no? So VE is V in times R pi divided by some sort of value, no, which is less than 1. Actually, less than 1, no? Kasi mananalo dito si GM eh. Like, this is 1 over 100K, 1 over 5K, 1 over 200, plus GM. I think GM will win because, like, GM is sometimes like 18 millisiemens or something. So, mananalo si GM dito. So, this is basically R pi over 18 millisiemens, which kind of multiplies it by around 1,000. Anyway, just trying to see if I can make sense of the equation first before we do anything else. Well, anyway, in terms of like an exam or anything, right, or a problem set, given yung lahat ng value, so actually you find that VE is equal to some sort of multiplier times VE, so you don't really have to to do it. Kaso working with the letters allows you to build an intuition or parang an explanation or a deduction, no? In term to find um reasons, no? Kung bakit naging ganito yung stats ng circuit natin when we change certain things, no? Oh, okay. You're right, no? V in over R pi, no? So 1 over R pi dito sa taas. You're right. There's 1 over R pi times that. Yan. So, as Sir Sap1 said, tinetesting ko lang kayo. Sige, thanks for that. Sige, next equation is, we're going to do KCL at, anong kinukuha natin? GM. So, meron tayong I out, no? So, we're going to do KCL at V out, no? Ang KCL at V out is 0, but, that's still the output node. So, we have GM VB, I out is equal to GM VE minus V in times VE over R out, at plus VE over R out. Actually, this thing goes there. Minus, no? Minus VE over R out. No? Pag ganon, tapos pag ganon. No? Actually, let's put it all on one side. So 0 equals um, that's negative I out. No? So tama. So I out equals this. No? Right. So arranging, no, such that GM and R out, well, such that VE appears just once, no? GMVBE. Ito GMVE. Oo nga, no? VBE. So VE minus V in siya, no? So lalabas siya across R pi and lalabas din siya dito, no? R VE minus V in. Meron tayong plus GM dito. Right? So VE minus V in. Ito yung nangyayari kapag kinopy-paste mo no? Sorry about that. GMVE minus V in. Hindi, V in minus VE dapat to. You know what? Let's do this one again. So, VE minus V in over R pi minus GM times V in minus VE. Okay, tama yung lalabas. Plus VE over RE plus VE over R out. And that's all the branches na. Equals 0. And if you rearrange everything, no, this becomes plus GM VE minus V in. No? So this becomes plus GM. And then this is 1 over R pi plus GM sa taas. Alright. Tapos, KCL at V out, again, let's separate out VE. That's GM VE minus GM V in minus VE over R out. Yan. No? So, rechecking, no? I out is equal to I out plus negative I out plus GM times, baliktad yung sign nito kaya pala. So, V in minus VE, no? So, V in minus VE is VBE minus VE over R out is equal to 0, no? So, papalitan natin to V in minus VE. This is plus, this is minus. And so, we find GM plus 1 over R out tapos plus din to. Kasi negative si VE. Alright. And now, finally, we substitute 1 into 2. Alright? So, I out is equal to V in times this negative that times GM plus 1 over R out plus GM V in. So we have V in times, so I out over V in. Okay, sige, let's do I out over V in. Tapos GM prime. And then we get this. So I copy paste that. Then we have GM minus this. Tama? So GM minus that big thing. All right. So dimensionality check. This is in transconductance. This is in, well, unitless, no? Transconductance over transconductance times transconductance, tapos transconductance yun, no? So transconductance yun lumalabas. All right. How do we make it appear like this? Okay. So, what I'm going to do here is I'm going to multiply both sides by RE, no? So we have RE over R pi plus GM RE. Wow, nandiyan na siya. Anyway, RE over R pi plus RE over R out plus 1 plus GM RE times GM plus 1 over R out. Right? But actually, I don't need brackets there. So, tanggalin ko to, no? So, out na yon, no? So, I'm going to copy paste it and erase them, no? Para consistent pa din yung direction of solutions. So, tanggal yon, tanggal yon. Right. So, now this is GMRE over 1 plus GMRE. Hmm. Ang dami nating terms. Sige, saglit lang, ha? Sige, while I look into this, have the attendance. Right, attendance sent, and sige, let's take a 5-minute break while I look at exactly how this thing is supposed to reduce to the GMRE that we want. Alright, sige. Ano? People keep falling off the meeting, but sige. Alright. So, um, uh, figured it out, no? It's just that it looks really ugly, no, kapag node voltage yung ginamit natin and we don't follow the one in the slides, no? But I wanted to show you guys what happens dun sa usual system, no? Natin. But essentially, no, I distribute this over that. We get RE over R out over 1 plus GM RE, no? So ito, tanggal din yan, di ba? And so what we get is 1 minus GM RE over GM over 1 plus GM RE, no? And this form, no, 1 over X over 1 plus X becomes, well, okay, show na, no? So if this is X, this is 1 plus X over 1 plus X, then it becomes just 1 over 1 plus X, no? So actually, this becomes GM times 1 over 1 plus GM RE, no? So in fact, this is just GM over 1 plus GM RE, no? And this is the GM prime, all right? So after all of that math, no, what we get is the following fact, no? GM prime is actually the original GM divided by the degeneration factor, no? GM over 1 plus GMRE, no? That's around how much it is, no? And well, if you do this in a lab, then you'll find, no, that this equation actually does a lot of justice to the numbers that you see, no? Especially since due to the um transistor variations, no, mahirap makuha yung exact calculations mo sa breadboard. But with emitter degeneration, mas mababa yung effect ng fluctuations na yun, no? So you are more likely to see the actual results of your calculations working in the circuit, no? But again, no, we see 1 plus GMRE dito. Lumabas siya as GM, right? Sige. So finally, kulang tayong pages? No. Okay. So finally, let's calculate our in. So our in is V in over I in at 0 output, no? So that's why I copy pasted this thing, no? Kasi, well, 0 output pa din naman yung gusto natin, no? So let's do again KCL at VE to get this, no? So VE, again, no, VE minus V in over R pi plus GM times V in minus VE plus VE over R out plus VE over RE. And that's equal to 0, no? So again, what we get from this is probably the same one as last time, no? So that's 1 over R pi plus 1 over R out plus this is GM plus 1 over RE. And then VE minus V in. Kaso minus to, no? So that's plus GM plus 1 over RE minus V in times 1 over R pi plus GM is equal to 0, no? And we get the same equation from before. This is V in, no, VE is equal to V in times this part over this part. Yan. So that's that KCL again. And now, ang gagawin natin KCL this time is yung sa input side, no? So at V in. Kasi meron tayong gustong kuning property from I in this time, no? And this one is actually quite simple. Bakit? Kasi we find, no, V in minus VE over R pi is equal to I in, no? Yun lang naman yung kailangan natin. So now we have V in over R pi minus VE over R pi is equal to I in. And okay, so we substitute this now for VE. Times 1 over R pi din is equal to I in. Right? And ano natin gagawin to? V in over I in, which is R in prime, is now 1 over R pi plus this. Well, actually, it's minus, no? So minus. Yan. Alright. So first things first, ang gagawin ko, no? Well, okay. So, sige, let's do a spoiler first, no? This is R pi times 1 plus GM RE, no? So, nandito yung degeneration factor natin, no? But I'll show it via via algebra kasi um again, no, this is just is what happens in the slides, no? So if you want a more concise version, then of course feel free to look at the slides, no? But okay, so to get there, no, first what I'm gonna do is multiply R pi to both sides, well, both top and bottom, no? Which leaves us with this, no? So 1 over R pi plus GM over the bottom side, no? Next, what I'm gonna do is multiply RE to both sides of this, no? Ayan, no? And from here, we can see the ending na, no? So, ito matatanggal, ito, saka ito matatanggal. So, now we have R pi, well, let's keep it at green. R pi over 1 minus GM RE over GM RE plus 1, no? But we've seen this before. This is R pi over GMRE plus 1 minus GMRE over GMRE plus 1. Alright? And then, pwede natin siyang iakyat to get GMRE back. And this is Rn prime. Alright? So, we get this. No? So, this turns into GM RE plus 1 times R pi is equal to Rn prime. Alright? Sige. So, after all of that, finally, ano itsura? No? So, we had this, no? So, finally, let's talk about the emitter, degenerated, CE, amplifier. Right? So, VCC, RC, well, RL pala, RE, and then RB. Tapos, well, decoupled yung input, but there's an input voltage there and an output voltage here. No? That's the emitter degenerated amplifier. And this is the small signal model. No? We have RB here. We have RL here with V out. And then, kanina, no? We planned to make a unilateral small signal, a unilateral two-port model of the emitter degenerate amplifier. This part, no? So finally, since we know the values na, no? So Rn prime is R pi times 1 plus Gm Re. R out prime is equal to R out times 1 plus Gm Re. And Gm is equal to Gm over 1 plus Gm Re. We can substitute those values into this two-port network, no? And finally, what do we get? No? The final small signal parameters would then be these, no? So the input resistance of this, remember, no, the effect of RB and RL, no? The effect of RB and RL is to just add a parallel, no? So now, this one is R pi times 1 plus GM RE parallel RB. R out is now R out times 1 plus GM RE parallel RL, and GM is now GM over 1 plus GM RE. Alright? So yun yung nangyari dun sa small signal parameters natin. But, note this down, no? An interesting thing happens here, no? The gain for this thing is, well, GM prime R out prime, di ba? So that's negative GM over 1 plus GM RE times R out times 1 plus GM RE. Di ba? So magka-cancel yung degeneracy, di ba? And we get still negative GMR out, no? So you might think, okay, this is great. I added an emitter degenerate resistor. Hindi nagbago yung gain ko, right? And we expected there to be consequences for stability. But the thing is, no? Okay, that may be true for this thing, no? Because wala pa yung RL. Hindi natin nilagay si RL. This is ideally biased, no? So of course, the gain that you're gonna get is the intrinsic transistor gain, the one that goes around 3K, diba? This is the perfect gain, no? If we add RL, remember, no? This parallel RL thing, R out is around 30K, no? RL is typically like 1 to 2K, no? So what happens here? No? But actually, R out is, well, not just 30K, no? 50K above, no? 100K, ganun. You multiply 50K by something that's greater than 1. No? This is greater than 1. It's 1 plus something, right? Then it gets even bigger. No? You parallel it with something small, then the something small wins. No? It becomes RL. And now, what happens to our gain? Our gain turns into GM RL over 1 plus GM RE. And if you remember, this thing, the numerator, is the original CE gain. And now, it's divided by the degeneracy factor. No? Alright? So, in essence, ano nangyari? Emitter degenerate, no? Emitter degenerate increased Rn, which is good, no? An increased Rn is good kasi mas mababa yung loading sa input. Kaso, it also increased R out, no? Which is not so good. Kasi you'll be loading the next stage, no? Kung 50 ohm speaker yung next stage mo, that's bad, right? Also bad is decreased transconductance, no? Because that's your current to voltage gain or voltage to current gain, di ba? That's still a gain. That's still an amplifier property. And now, the saddest thing of all, no, is also decreased voltage gain, no? So this is by 1 plus GM RE, no? And I copy paste that to all of them because it's true, no? So we increase Rn and R out by 1 plus GM RE, we can decrease both gains by 1 plus GM RE effectively. All right? So with that, ends our lesson for today. Be sure to do the attendance. I will delete it by 5:30. And I'll see you guys tomorrow for the exam. All right? Sige, with that, thanks guys and good luck tomorrow.